Hey everyone, and welcome back to PrepFusion. So today we will be discussing the most important topics for GATE EE aspirants. So in the previous video you have already watched the EC syllabus and most important topics depending on the weightage. In this video we will discuss about EE. Also I will be discussing about the free resources from where you can cover a topic, right? I will obviously give you a priority wise list, which topics to focus more on, which topics to focus less. So all those things I will provide you a list. Don't worry about it, and I will tell you as well how can you cover it in a fast manner, and everything will be free. It's not like I will tell you something like that will some cost some money. No, I'll mostly try to say whatever resources I will explain you, everything will be free. And please listen to me very carefully whatever I say throughout the video. Don't just take the screenshot and make slides of it. Like every single thing whatever I will say is very important, right? Which topics to focus more on, which topics can you give less emphasis. So obviously first, there are mostly 12 subjects. In electrical there are 12 subjects, in EC there are 10 subjects, which is less. In EC there is less number of subjects, that is fine, but electrical as well, if you study in a smart manner, you will be able to achieve a good rank. So network analysis and signals and systems. So first I will discuss about network. Network mainly has 4 chapters. Not 4 actually, there are multiple chapters. We have divided it into 4 sections: basics, theorems, network theorems, and transients. So what I will suggest, if you want to save bit of time, right, you can, these 3 are the most important ones. So by now I hope you have already covered it. If you have not already, I will tell you the resources as well. After this, AC circuit and 2 ports. For electrical aspirants, AC circuits is again very important. For an EC aspirant, it was not so much important, but for an electrical aspirant, it is very important, because ultimately in the next stage, right, next chapters, you will use AC. So this is also very important. But if you are running less in time, I have covered these 2 topics in RPYQ series. Okay, in a single, the video is around 8 hours. So in 8 hours, I believe you will be able to cover most of the things, and then after watching those 8 hours, you go and solve the gate PYQs. I think for AC and 2-port networks, you will be sorted. For 2-port networks, you don't need to give much focus, because ultimately there are few set of equations that you need to use to solve the question. That's it. Few things are there, certain things. So 2-port is very easy, but give your full focus to basics and transient. That will be very useful. In signals, for an electrical aspirant, right, I cannot surely say like what is important, what is not important, but I will give bit of star mark. So basics of signals and systems, and basics of signals, basically, of course it is very important. You cannot ignore it. This basics chapter is always very important. You cannot ignore it. Like you will at least get 2 to 3 marks from this particular 2 chapters: basics of signals and systems. These are 2 chapters. Then we have continuous time Fourier series and continuous time Fourier transform. Actually, yeah. So for an electrical aspirant, if you are running very low in time, right, you can just cover the continuous time Fourier transform. That's all. Okay, you don't need to cover like, of course you will study CTFS and CTFT both, but if you are an electrical aspirant and if you want to cover in a quick manner, then maybe you can cover these topics from a crash course, maybe. Okay, if you are running less in time. But if you are studying comprehensively, there is no problem. So if you have already finished all of the syllabus, if you are very close to the syllabus completion, then you should not watch the video, drop this video and study. Okay, but for those students who are running bit less in time and who want to cover few important topics, they can watch this video. So as I have mentioned, you can cover these 2 topics: continuous time Fourier series, continuous time Fourier transform, in crash course. Now Laplace transform and Z transform, again very important. I have seen this has very good weightage. In electrical, they ask question from Laplace transform and Z transform. Now the thing is, right, it might happen this year, they might not ask question from Laplace and Z. They might ask more question from CTFS and CTFT. That might be the case. I'm not sure. So they can give you a curveball. What I'm doing, I'm just analyzing the previous year papers and telling you which portions are the most important ones. Okay, from where questions mostly come, but the pattern can change as well. So DTFS, DTFT, I will say if you want to skip, you can skip. Not that super important. If you want to skip, you can skip. The continuous part is the most important one in the signals and systems. Of course, covering every single thing is very important. FFT is anyways not in the syllabus till DFT is there. Okay, but if you want to skip, you can skip. For EC, it is very important, signals, because it is their base subject. But for EE, it is not. For EE, AC circuits and network is completely important. So from where you can cover, as I was mentioning, this 8 hours video is there, RPYQ. So these are the topics that you can cover in this single video. And for signals, if you want to cover basics, like I told you, right, basics of signals and basics of systems is very important. If you cover these first 5 marathons in our playlist, signals and systems, this first 5 marathons, then you are done with the first 2 chapters. So you don't have to worry if you watch the first 2 marathons, that is more than enough. Let's now move on to the next subjects, analog and digital. Again, for EC, analog and digital has very good weightage, but for EE, they don't have much weightage. They have around 5%, 5% weightage only. So what I will recommend, you cover both analog and digital from any crash course, right? In YouTube, you will find many crash course. You can just search whatever educator you are comfortable with. You can cover both with crash course. Okay, both of these. No, like there is no same. Like of course, covering it comprehensively, it is always better. But if you are running late in time, so you can cover them from crash course. There is no problem. Cover the crash course and then solve the gate PYQs. Okay. So BJT as well, don't skip BJT. They can ask a very simple question from BJT. So BJT has just the current equation IC, and we have the active region, saturation region, the DC biasing. So DC biasing of both MOSFET and BJT, right, are very very important. Maybe they will focus less in AC biasing, not sorry, in AC analysis. The focus will not be that much, but DC biasing, right, is very important. How do I bias my MOSFET? The DC analysis basically is the most important part what I have seen. And op-amps, again, everything is important. In op-amps, I cannot say this is important, that is important, but obviously most of the questions will be solved with negative feedback and virtual ground concept. Okay, so if you're running less in time, you can cover it from a crash course because the weightage is much lower. And in digital as well, mostly they will ask you questions from uh, like basics of digital system, combinational, sequential, and ADC and DSC. These two are the obviously the higher weighted subjects. After that, basics of digital systems and ADC, DSC, Boolean algebra, all those things come here, right? K-map, Boolean algebra, all those things come up here. So of course, without K-map, you will not be able to solve any combinational circuits. So you will have to study this anyway. So basics is always important. So study it and cover combinational. Sequential, if you feel like it is a bit difficult or if you are not getting enough time, again you can like cover it in a smart manner, right? So that maybe the most important things that you can cover. You don't need to cover FSM, right? Finite state machine is not in W. I have not seen any questions from finite state machines, but mostly the flip-flops. And next, like just understand the next state equation, how to calculate the next state equation, and how do I characterize my flip-flops. If I have like there is a flip-flop conversion, let's say I have given XY flip-flop. If I want to make a JK flip-flop, what shall be the connections? So those things they can ask. So I have heard, mostly I have seen these kind of questions. So if you just solve the gate POQs of both of these subjects, right, for EE, don't try to solve for EC, right? For EC, you will feel like the questions are a bit difficult. That is because that is their core subjects. Analog and digital are not our core subjects. So, but of course, they can ask difficult questions. I'm not denying the fact they cannot ask difficult questions. They can. Everything is important. They can. It's their wish. But mostly the pattern is they have asked easier questions from analog and digital. So mostly what you'll do, you'll cover digital and analog from crash course, digital and analog from crash course, and then you will solve the gate POQs of EE, not EC, of EE, and that should be enough. If you are not able to solve the gate POQs, that means you have to study it in a better manner. Maybe you can switch. So first, I will recommend at least you study the diode circuits in a good manner, right? Diode circuits completely is covered on YouTube on PrepFusion. You can cover it, and of course cover the basic of digital electronics and combination circuits. These two things you cover from PrepFusion, right? Then after that you can move on to the other things. Okay, I told you to cover it from crash course, not everything. So these at least cover the basics of diode, or if you want to cover it from crash course completely analog, you can cover it. But of course we know that for analog, Himanshu sir is the best. So that's why I'm recommending it. But if you feel like, no sir, I don't have enough time to watch these videos, you can cover it fully from crash course. But I am telling you, if you want, you can cover it from here. These are the best resources. But if you are running late in time, of course, there are other resources on YouTube as well, and there is no problem in following that. Now let's come to the next subject, control. Again, control is very, very important subject, very high weightage subject. We have basics, SFG, BLR, time response, RS criteria. Like here, right, I cannot pinpoint a certain topic that is less important. What I can say is, yeah, state space and controllers, maybe it is not super important for IN aspirants who are from IN, right? for IN aspirants, controllers is very important. So if you are a GATE EE aspirant and if you are preparing for IN, controller becomes a very important topic. If you see the previous year question, like there will be at least 4 to 5 questions from controllers only, and it's not like it is very in depth of controllers. It is, you will use basics of control systems, whatever you learn in time response in basics, and then you will use that in controllers, or maybe whatever you learn in frequency response you will use that in controllers. So there is a mixed question which involves two topics. So yeah, so that is the thing over here basically. So yeah, what are the less important? So maybe state space and controllers, if you are a EE aspirant, then this you can put on low priority. And polar Nyquist Bode plot, again high priority. This is very important, right? This is very important topic. Root locus again is very like important. I can give it a 2-star. Time response, again it's a 3-star topic. Like every year there will be at least one question minimum. Okay, RH criterion, maybe you don't need to give that much high of a priority. What is RH criterion? How to use it, that is the most important one, because you will use RH criterion everywhere in Nyquist plot, in frequency response as well you will use it. And basics again is very important, you cannot ignore the basics. So how can you cover it in an efficient manner? If you have already previously studied, then you can follow my RPYQ series of control system. It will be totally revised, right? Whatever you have studied, and trust me, you will learn a lot of new things. Whatever I have taught in my full course, those things and tricks I will use here without memorizing any single formula, without that. So those things we will use. And yeah, so that's how you can cover control systems. If you want to cover crash course, you can cover it from my crash course RPYQ series, or you can cover from any other crash course, whatever you find suitable, you can do that. But I have told you what are the important topics, what are the less important topics out of here, which topics to focus more on. Engineering mathematics, again, what are the most important topics? Linear algebra is very important. Calculus includes the differential calculus, like limits, continuity, differentiability, then differentiation, application of derivatives, and after that integral calculus. So again, these like calculus is very important, but it's very lengthy as well, right? So but you have to study calculus. If you don't understand calculus, you will not, like, you are not a good engineer. So you have to learn calculus. And then vector calculus, these are vector calculus, vector and complex variables, and then probability and statistics. Actually these are the highest weighted topics. And if you are very good in mathematics, if you're very good in mathematics, you can just follow my RPYQ series. That's all. Okay, I can say mathematics we have learned everything from basics to scratch with my RPYQ series. Currently probability and statistics is not been uploaded. When I get the time, I will definitely upload probability and statistics. Now differential equations, you will say it has low weightage, should I skip it? No, don't skip it, right? They ask a very easy question from differential equation, and I have already covered the differential equation here in this integral calculus video. So don't skip differential equations. Okay, it's very simple. They will ask a very easy question on it and you will be able to solve it. I think you have to give 3 hours, 3 to 4 hours. I think 3 hours. If you just watch, I think differential calculus was at the end, and I gave differential equations. I think I gave this marathon 3 hours, and before that we were learning integral calculus. So just cover it from here only, from this video only, you will be done in this video. Okay, in this video differential calculus is covered at the, not differential calculus, sorry, differential equation is covered at the end. So yeah, you can cover from this video, that's it. Or if you want to cover completely mathematics from crash course, you can cover it from here. Of course, if you are doing comprehensively, no problem. But I cannot say for mathematics that one topic is less important. No, everything is actually important. Statistics, you might feel like, yeah, you can, it is less important, but the thing is, it will not take you much time to study statistics. Okay, it will not take you much time to study statistics. Probability, again, it has multiple things, right? Basis of probability, then random variables. So there are two parts: basis of probability and random variables. So basics is very easy, not that difficult to like solve if you are very good in mathematics during your JEE days. And then we get the random variables, that is a new topic. That for that you need to give a bit of effort. So these are the things regarding engineering mathematics. Now I will come to a core subject, that is power electronics. Now power electronics, here I can actually say to you which are less important, which are not that, which are very important, right? Rectifiers is very important. Okay, you can cover it comprehensively. That is completely covered on YouTube PrepFusion. Okay, if you search power electronics playlist on YouTube PrepFusion, rectifiers is completely covered except the 3-phase rectifiers, that is low priority. Okay, give 3-phase rectifiers low priority. They can ask a question, but again, that is low priority. After that, choppers is also a very, very good topic. Maybe I will upload a marathon. Let me know if you want the marathon, choppers marathon. You can comment down below in this video if you want the choppers marathon. Maybe I can bring the choppers marathon. And trust me, the way I have taught you, you don't need to like remember any formula. No formula is required. Right? Literally no formula is required. Without formula also you can simply solve it. Okay. Inverters and semiconductor devices. I will recommend do them from crash courses, because in inverters mostly they have some formulas. You just have to understand how to remember the formulas. That's it. How to remember the pulse width modulation. Then we have 180-degree conduction mode, 120-degree conduction mode. Right. So of course derivation is important, but I feel as exam is near, so maybe you can cover inverters and semiconductor devices, right? Mainly in semiconductor devices, SCR, the most important topic is SCR from semiconductor devices. The concept of latching current and the concept of holding current. These two are the most important topics. Mostly if you solve the gate POQs, you will see the questions getting asked in the concept of latching current only. So SCR is very important. You can cover these two chapters from crash course, and of course in choppers everything is important. And if you want, I can upload the marathon video, and there you can see that you don't need to remember any formulas. Okay. Now general aptitude, what I will recommend is just solve the PYQs of from gate 2027, sorry, not 2027, sorry, gate 007, gate 2007 to gate 2025, and you are good to go. If you feel like if you are not able to solve most of the PYQs, or if you are not able to solve a particular kind of PYQs, then what you can do is you can search for that particular topic. So we have a playlist, aptitude simplified. Okay, in that playlist every single video is already covered, every single topic of aptitude is already covered, but you don't need to watch those videos actually. If you're comfortable, like mostly engineers are comfortable in like this quantitative aptitude, analytical aptitude, and spatial. Verbal is the English part and a comprehension part, right? Comprehension you will be able to solve, but the English grammar part or the synonym part, mostly engineers are not good, and whatever you do, trust me, you'll not be able to perform good in that. Like you, if you remember 5,000 words, maybe they will ask from a word, right, that you have not learned or you don't know the meaning of. So there is no point in studying English. Just study these three things. Okay, English is on your luck. If you know, you know. If you don't know, skip it. Don't attempt that English question. So my recommendation will be to solve the gate 2007 till 2025 PYQs, and uh, first you can watch these videos. Like we have solved from, I think, gate 2018 to gate 2025. Okay, all these PYQs have been solved already. So my recommendation will be first you watch these videos. Okay, don't watch the solution. Pause when we are showing the question. Pause the video. Try to attempt the question by yourself, and then you see the solution if we are saying something new and if your answer was correct or not. Then after you are very comfortable in all these things, right, after watching these videos, then you can move on to solving the previous year questions, like before 2018, 2017, 2016, and so on. But if you're not comfortable here, then as I was mentioning previously, you can just search for that particular topic, whichever topic you're not comfortable in, and you can watch that. Like in this playlist, everything is covered. I'm just showing you the PYQs, but the topics, conceptual topics are also covered. Theoretical things are also covered if you go into the playlist. So you can watch that particular video. As we don't have enough time, that's why I'm not telling you to watch everything comprehensively. I'm telling you how can you save your time. Next, core subjects. Two core subjects we have: electrical machines, power systems. Again, very important. Electrical machines. Unfortunately, I'm extremely sorry. I cannot say you can skip that, you can skip this. Everything is important. Okay, but mostly what happens in transformer, the single phase transformer again is very important, more than three phase. So there is three phase transformer, single phase. Give more focus on single phase. DC machines, it is very easy chapter, very easy chapter. Mostly like you know, right, whenever we have DC, things become very easy. So don't skip DC, never skip DC. Study DC in a comprehensive manner. I will say if study everything in a comprehensive manner from electrical machines. Induction machine, there are a few formulas here, but if you study in a good manner, you will be able to understand mostly the things and from where they ask, right? So they are mainly, either they will ask from the torque equation, or they will ask from induction motor machine starting, or maybe they will ask if they will give you some slip and they will ask you to calculate the speed or something they will ask, right? Synchronous machine again is a very important chapter, because if you understand synchronous machine, you will be able to also understand fault, the stability part especially, because stability we use the concept of synchronous machine only, right? So that's why everything is important here. How can you cover? If you want to cover comprehensively, we have a playlist of electrical machines, comprehensive playlist. You can cover from that. If you want to cover it from a crash course, you can, but I will never recommend electrical machines to be covered from crash course. This is a core subjects. This is a core subject of electrical domain, so I will not recommend it. Next up, we have power system analysis. So after studying all this, after studying the synchronous machine, I will recommend you directly move on to the fault part. Fault, stability, load flow, right? So load flow you can study later. Fault and stability, these are again very important chapters. Fault analysis and stability. In fault analysis, again there are multiple kinds of fault. Mostly symmetrical fault is the most important one, okay, and sometimes they ask from unsymmetrical as well. And trust me, if you watch this video, right, like not this video, this playlist, here I have covered fault, stability, I have covered the transmission part, bit of the transmission part in a better manner. So I will tell you to cover these topics, right, whatever I have covered in the YouTube video from my playlist only, and other things you can cover it from crash course, like economic load dispatch. This is a very small topic, but this is a very high weightage topic. I have seen at least one question get asked every 2 years. Every 2 years, at least one question has been asked from economic load dispatch, and it is just a topic. So this is a very rewarding topic, and this will not take you more than 2 to 3 hours to study, and you are getting one question, either of 1 marks or 2 marks sometimes. So very good topic, mostly 1 marks only. So I will suggest you study economic load dispatch. So fault stability is very important. Load flow is also important, but not super important. I will give it 2 star. Economic load dispatch, again I will give it a 3 star, because every other year I am getting a question, and the length of the topic is also very small, not very large. Then we have transmission and distribution. In transmission, mainly you have to understand the formulas of L, R and C. That's all. In different chapters, you will have to understand the formulas of L, R and C, right? Inductance, capacitance and resistance. There will be high like long transmission line, short transmission line, medium transmission line. So what are the approximations? Those things you have to do. So I have covered that. I have covered the, like, there is a parameters of transmission line and performance. Performance is, again, you'll not need to remember much stuff, right? How to improve the power factor, how to improve the power factor. These things they can ask. With the capacitor bank. So very important topic. I have seen the question getting asked from this particular topic, and other things also they can ask, but mostly performance is not that difficult to study. So that's why like I've covered the most conceptual part. It is not difficult to study. Performance is not difficult to study, but it is conceptual. If you understand the concept, you will be able to solve. Because I feel whatever is difficult for me is the part where I have to remember the formulas. So when do you have to remember the formulas? The parameters of R, L and C. There are so many formulas, right? There is a formula for inductor, there is a formula for capacitance, right? Both are quite opposite of each other, if you remember. Then there is a formula for inductance with earth considered. Then there is the effect of skin effect. So there is R dash, right? R dash was equal to 0.7788 R. So I hope you're remembering few things. So these are the things basically. So that's why there are so many things, formulas to remember in RLC. So you can cover that from crash course. You can just note down what are the important formulas. You can solve the git POs and see from where the questions are mostly getting asked from these topics, right? Performance is conceptual. You don't need to remember, but you have to learn how to solve a circuit. So for that you'll need a bit of learning, bit of understanding. So that's why I have covered those things in YouTube. Whichever part you will feel like you will need bit of explanation, which you are not able to understand conceptually, those parts already has been covered, like the difficult portion, right? Conceptual portion already has been covered in YouTube. So those things you can cover from YouTube, and the rest of the parts I will suggest you can cover from a crash course. That is my suggestion. Again, power production and power generation, again I will suggest this particular topic to cover from a crash course. protection. Like in protection, right, there are relays. There are relays. Relays is a very important topic. Switchgear maybe not super important. There are few formulas of switchgear, not super important. But relays again is very important topic. Circuit breakers, again there are multiple types of circuit breakers. Like they can ask a theoretical question. There are few numerical question as well. But mostly I assume that they will mostly ask. They will mostly ask from the this part. Relays only. That is my expectation. Like there is distance protection as well, but mostly I guess they will ask from relays. Okay. Like there is a plug setting. Like there is a PSM and time setting multiplier, right? Plug setting multiplier and time setting multiplier. So there is a concept of these two things. So you have to understand these and solve the question. So yeah. So these are the important topics for PSA, power system analysis. Now two subjects are left, that is measurement and EMFT. So in measurements and EMFT, don't take this lightly actually. They mostly like 3 to 4 marks actually mostly come, sometimes higher as well, but mostly 3 to 4 marks are getting asked every year from measurements and EMFT. So what are the most important topics? Analog instruments, okay, bridges anyways you don't need to remember, but just learn how to solve the bridges. Analog instruments is most important, and then electronic measurement. So these two topics already has been covered, right, in YouTube, in the measurements playlist. So if you just follow these two videos, you are mostly good to go. Like you are securing at least 2 marks, at least 2 marks. Okay, the remaining 2 marks they can ask from these topics: error, resistance measurement, then bridges, right? So for these, again you can study it from any other crash course if they have, but I don't think there are many crash course on YouTube for measurements. You can search for it. I think someone will do it. But if you are not able to do it, right, if you just go into the RP Baiku, okay, and just download the notes of my measurements and just study from there, that also will be enough. That also will be more than enough, right? Now, so what you do, just watch these two videos, and the remaining you can study from notes. Okay, or if you want to study from any other crash course, that also you can do. I'm just telling you whatever we have already provided, right, for free, that you can utilize that. Now coming back to EMFT. EMFT has this coordinate system calculus. Now this, right, I'm expecting this you have already covered in a good manner in vector calculus in mathematics. So if you have covered this in a good manner, maybe you don't need to cover it, but mostly sometimes like the question from vector calculus also is asked here on the EMFT domain. But most important topics are electrostats and magnetostats. You can cover it from a crash course, any crash course if you feel like, or you can cover it from my playlist as well. I don't think the length of this playlist is much high. I'm expecting it will be something around 10 to 15 hours, or maximum it will be 20 hours. So you can cover it from here as well, the electrostat magnetostat part. Electrostat magnetostat part would be around 12.5 or 15 hours. And electrostat, there are many things, right? First of all, there is electrostatics, then there is capacitance. So both of them are actually important, but I will say the basis of electrostatics, right? Charge, force in a charge, Coulomb's law, those things are more important, electric field, than capacitance. But capacitance they can also ask, but I have seen mostly they ask from Coulomb's law, then electric field, those things only. Then time varying fields, again not super important topic. I will give this as a lower priority, but again previous year actually I feel they have asked a question like this basic formula: V is equals to minus d phi by dt, right? My voltage is rate of change of flux linkage, total flux linkage. So they can ask question, right? Previous year they have asked, but this is low weightage. Mostly first of all they will ask from electrostat magnetostat, then they'll move on to other subjects. So I will say, if you are running late in time, cover this EMFT from any other crash course, because I have not provided EMFT crash course, so you can cover it from any other crash course. Measurement part, I have already covered the most important parts, right, from where they will ask questions. The remaining parts you can maybe cover it from other places, right? Or you can just watch the notes. So yeah, that's basically it from my end. Just a small info, right? Currently huge discount is running on our website on all the GATE 2026 courses. If you apply the code GATE40, right, you will get 40% off on all GATE 2026 courses. Now this code is also applicable for GATE 2027 courses as well. Okay, so maximum you will get 40% off for GATE 2026 courses. This code, same code is applicable for 2027 courses as well. You can apply. So for all GATE courses, you can apply this code, and for placement courses, for all the placement courses, you can apply job 20, the code job 20, and you will get 20% off. You will get 20% off on all our placement courses, and you will get 40% off on all our GATE courses for the GATE 2026. Okay, for other courses the discount, like this is the highest discount that we're providing, 40%. For the other courses, like for 2027 2028 courses, it might be a bit on the smaller side. So that's it from my end. I hope you perform very well in your examination, and don't just see this like I will study only the important topics, I will not study the less important topics. Everything is important, of course. You never know from where they will ask the question, that is the beauty. But if you're running really less in time, then you can make a smart decision, and maybe you can prioritize the important topics first, then you can study the less important topics if you get the time. That's it, and I will see you in the next video. Until then, happy learning.